Okay, so this is we visit back our example one. Okay, I give you RC circuit, and then from this slide you can see how we derive the transfer function based on mathematical equation. Okay, this is we call it mathematical equation. Okay, based on the derivation. So for today, I want to share how we want to define the transfer function using block diagram reduction technique. Okay, how you want to get the transfer function using block diagram reduction technique. Okay, but hopefully you still remember the table. Okay, table that show the relationship between impedance, impedance for component, capacitor, inductor, and resistor. Who still remember the impedance for capacitor? Who still remember the impedance for the capacitor? Siapa ingat apa impedance for capacitor?
1 over Cx.
Yes, very good. Okay, impedance for capacitor is 1 over N. How about impedance for resistor? How about the impedance? The impedance? Impedance. How about the impedance for resistor? And how about impedance
This is
for
R.
R.
okay, impedance for resistor is R. How about the impedance for inductor? L.
LS.
Yeah, good. Okay, now we already know the impedance for this electrical circuit for RC circuit, meaning RS the equivalent. Okay, for this circuit, example one, the equivalent impedance. Okay, hold on. Impedance. Equivalent transform impedance. Okay, capacitor 1 over Cs, resistor R, and inductor Ls. Okay, so let's say uh, I draw back the impedance. I draw back the circuit. Uh, uh, Five, current, and this is our uh, impedance for resistor, and this is impedance for the capacitor. Okay, and this is the output. Okay, so we use this on guiding principle. We're going to use is a Kirchhoff law. Okay, so from that circuit, so we know VR is our applied voltage or our input voltage, and V naught is our output voltage. And then you have to define the transfer function is V naught over VR in terms of S domain. Okay, so we want to define the transfer function. Okay, first step, you have to derive the equation for the total voltage around this loop. Okay, so meaning the first equation equal to in terms of S domain. We directly put in terms of S. Okay, we equal to what's the total of voltage around the loop. So meaning R multiply with the IS and plus what? Plus CS multiply with the IS. Is it correct? Like this? Total of voltage around the loop. Inside the loop. Is it correct? Is it
Yes.
correct this question? Okay, this is question number one. Okay, but we also know V naught our output voltage equal to our voltage capacitor, right? Okay, so meaning our V naught equal to what's the voltage capacitor or capacitor voltage?
One
Capacitor voltage is
one over CS.
multiply with the current.
Oh yeah.
Okay, very good. Okay,
Yes.
question number two. Okay, right. So we substitute equation 2 into equation 1. So we can get RS equal RIS plus V naught S. So I can get this equation. Is it correct? Substitute into 1. So I can get equation number 3. Is it correct? Class, are you with me?
Yes.
Okay, okay, right. So now we have already V0. So meaning in your derivation, you have to uh, rearrange the equation until you get this one, not and so VI. Sorry, okay, this is your input. Okay, this is your VI. Okay, so in your equation, you have to derive until you get this one in term of V naught and VI. Okay, so now we already have our input here, VI, and we have our V out here. And V naught, and this one your input based on equation number 3. Okay, so from equation number 3, I want to show you how to draw the block diagram. Okay, so for equation number 3, we rearrange the equation to get I minus not equal to R I S. Is it okay? Everybody can
Yes.
follow? Everybody can follow, right? Okay. So we can
Yes.
get question number 3. I rearrange to make it, let's say I put question number 4. Okay. So from here, I give you one, like, like hint, or maybe we can say how to derive the equation before we draw the block diagram. So you have to represent your equation like output equal to gain multiply with the input. Okay, this is the like a keyword lah. Okay, it's like a keyword. How to derive your equation before you draw the block diagram. Okay, now from question number 4, which one our input and which one our output? Class, can you give the answer? Which one input, which one output? From question number 4. Hmm. Mana satu input, mana satu output? So nak tahu input kita tadi apa dekat kita punya circuit? What's our input to our circuit? Voltage, right? Is it?
VI.
Okay, this is our input, right? This is our input, right? Okay, so meaning now voltage is our
Yes.
input. Okay, and then voltage is our input. So meanings we have how many input we have? Voltage and voltage. We have V1, sorry, we have VI, we input, and we have V0. How many input we have? From here. From here, we have 2 input. Okay, so meaning
Two.
how to sketch or how to draw the block diagram. Okay, if voltage, if your input, so meaning how about the current? How about the current? Current is your output here. And then R is your gain. Okay. Class, do you remember our component is a RLC. Our circuit is RLC. So RLC is going to be your gain. Okay. Whether R or L or C or combination for RLC or Accentra, that is going to be your gain. Okay. Meaning the variable inside the block diagram RLC. So right apa variable inside your block. Okay. Voltage or current that's going to be whether your output or your input. Okay, hopefully you can uh get the information. Okay, voltage or current could be your output or your input. The component or the passive component can be to your gain. Okay, gain meaning the variable inside the block. Okay, so from here, how to sketch equation number 4? We have two inputs. Meaning, we have a summing point here. We have a summing point, and then the first one, of course, we use VI because VI is the applied voltage to the circuit. Okay, the second input is the V naught. So, how about the sign here? The sign is minus. We put minus here. Okay, guys, follow? Okay.
Yes.
Before I forgot, so you have to rearrange equation number 4 to follow this segment. Output equal to gain multiply with input. So you have to rearrange, right? Equation number 4 before we draw the block diagram. How to derive the equation? So equation number 4 is going to be how to derive? Right. Derive the equation number 4. So you follow the keyword current equal to 1 over R and multiply with the VIS minus V naught S. Is it correct? This is Madam level number 5. Is it correct?
Yes, madam.
Question number 5. I rearrange question number 4 to fulfill the statement output equal to gain multiply with input. So I can get equation number 5. Is it correct? The resistor I bring to the left, so I can get 1 over R,
Yes.
right? Okay, for equation number 5, we can draw the block diagram. How to draw the block diagram? Okay, we have two inputs, so meaning we have a summing point here. Okay, this is the VI, this is the summing point, and minus because we have minus there, and this is a V naught. Okay, this is a V naught. V naught S. Okay, what is the gain? Gain is a 1 over R. Okay, what's the output? Output from here is a current. Okay, this is the block diagram represent equation number 5. Okay, class, you follow?
Yes, madam.
Okay. Oops. Okay, now the next. What is the question just now we derived? The V naught. Because from here, question number 5. Okay, we have another one question related to V naught equal to capacitor voltage. Where just now? V naught equal to capacitor voltage. Okay, this one. This one is it? This is V naught. Okay, we come back to question number 2. Alright. V naught equal to voltage capacitor, and voltage capacitor equal to 1 over Cs multiplied with the current. Okay, so after we finish, equation number 5, you have to find out where is the equation related to this one and this one. You have to come back to your list of equation and then which include current and voltage just now. Okay, so meaning the equation is apa equation dia tadi? Uh, E naught S equal to 1 over Cs multiply with the current. Oh, sorry, with the current, right? This is question number 2. Okay, so from this equation, we already have a current here and we out here. Okay, so you refer back to the first block diagram. This current is your output, is it? From the block. Is it correct? Is it true? The current is your output from the block. Is it? Betul tak Mio? Okay. Mio tak
Yes.
sihat ke? Mio? Mio sihat ke tak sihat ni?
Sehat.
Sihat. So okey tak? Internet semua okey tak? Boleh putus-putus? Tak clear,
Phone
putus-putus.
yang
So Din
rosak.
okey ke? Din okey tak?
Putus-putus madam, jauh suara madam.
Ya ke? Alamak. So now tak? Testing. Suara
Okey.
madam tak ada rasa. Okey dah? Suara madam kurang jelas. Alah kenapa? Madam punya internet pun merajuk ke? So macam mana? Is it clear? Tak clear kena bagi tahu. Madam tak baca chat. I tak baca. I tak baca chat. I jalan je. So clear ke tak sekarang? Okay, much better. Sebab saya tutup pintu. Saya tak boleh tutup pintu. Kalau saya tutup pintu bilik saya ni, dia tak bagi wifi masuk. So saya kena buka pintu. Okay, biar satu rumah saya dengar saya mengajar. Macam medium cakap dari KL tapi laptop dia kat Kedah. Okay lah Mia, sorry. Sekarang clear tak?
Clear.
Okay, right. Thank you. So nanti tak clear lah sebab Mia tak baca chat. Sorry Okay. So kita kat mana tadi? Equation number 2. Okay, equation number 2. Until this, any question? Okay, sebab tadi tak clear kan? So far, until equation number 2, everybody can follow?
Yes.
Okay, we start derive equation. Equation 1, equation 2, and then equation 1 we rearrange to follow the output equal to gain multiply with the input. Okay, and then we draw the block diagram. Okay, and then we come back to example. Equation number 2. Okay, equation number to redraw equation number 2, you have to find out now what is our output and what is our input from equation number 2. Which one our input and which one our output and which one our gain? Which one? Which variable going to be our output? Which one our output?
BO.
BO our output. Okay, meaning our input is a current. Okay. So here is a current. Okay, so if the first block current is your output, right? Okay, current is your output. So meaning the second block or the second subsystem, the current is your apa? Is your input. Okay, maksudnya dia bersambung tau. Kita ada banyak. We have a lot subsystem. And then if the first block current is your output. The second block, current is going to be your input. Okay? So meaning, how about equation number 2? So meaning, um, so current input, voltage is output, and this one is your gain, right? Is it correct? Our equation number 2? Guys, are you with me?
Yes, madam.
Okay. Okay, so from equation number 2, we start draw the block diagram. How to draw the block diagram? It's your input. Okay, so meaning this is our input. Our input is a current. Okay, this is IS. IS input, and this is our in, and what is our output? Our output is a unit. Okay, this is the second block. Okay, from here we combine. Okay, we finish write all the equation. Is it any equation? We only have two equations for this electrical system. First is equation one. Equation 1 meaning the total of the voltage around the loop. Okay. And then the second equation to show relationship between output voltage and the capacitor voltage. Okay. So we finish meaning from this system we only have two equations. Okay. So we only we already derive the equation and draw the individual block diagram, and then the next step we have to combine the block. Now we have two block, right? We have two individual block, okay, or we have two subsystem, and then we have to combine. Okay, first, okay, we have the input. Okay, and here we have 1 over R. And our second system, 1 over CS, the output, the current. Okay? Between block A and between block B, we have a current. Then output is the unit. Okay, and here also unit, right? And then we pick back here. So we can get overall block diagram. Okay, this is our overall block diagram. Our represent what? Represent our example number 1. Where is example number 1? Where is the circuit? Okay, this one. Okay, this is our circuit number 1. Okay, so this is the equivalent. Okay, the equivalent transform impedance. This one. Okay, we re, uh, we we redraw the circuit and we label the impedance of component. Okay, meaning R, the impedance is R and the capacitor is 1 over CS. Okay, so from the system we already get the block diagram. Okay, so from the block diagram, how to define the transfer function? How to define the transfer function? V naught S over VIS. How to define the transfer function? sorry. How to define the transfer function? We have two block here. We have A and B. Okay, how to define the transfer function? Your class, you still remember we have three basic form. How we want to combine block A and B? What type of form for A and B? Tahu what type of form for A and B?
Combining.
Is it suara madam tak jelas lagi
Ya, madam, putus.
Ya, putus-putus Alamak. Kenapa ya hari ni madam punya internet pula merajuk. Tak best ni. Suara madam tak clear. Ya. Nak buat Kita tak tahu nak cari pergi mana. Sekejap sekejap. Okey ke?
Okay,
Dah, clear dah. Okay, right. Sorry.
clear.
Okay. So now kita start balik. Okay. How to macam mana? How to reduce instead of two block, make it one block. Apa? What type connection yang ada kat sini? What type of form we can get here? Cascade, parallel, or cascade? Yes, very good. Okay, we have cascade. So meaning we cascade A and B, right? So we cascade A and B. So meaning we can get 1 over RCS, right? Okay. And then V naught. This is VIS. Okay. This is a minus. Okay. From output, we feedback here. Okay. This is also V naught because this is a summing. This is a peak off point. Okay. The signal V naught here is also same here, meaning here also V naught. Okay. Okay, so the next one, what type of connection here?
Feedback.
Okay, good, feedback. Meaning H equal to? H sama dengan berapa?
1.
Okay, very good. H equal to 1. Okay, so we apply feedback form here. So meaning, once we apply the feedback form here, so summing point ni akan hilang lah summing point bila kita when we simplify this looping, okay, the summing point is consider missing, okay, from this block diagram. Okay, so meaning directly we can get our transfer function output over input equal to 1 over, okay, lagi sama. This is minus, so we get plus here kan? Okay, we get plus R CS and multiply with 1. Okay, so you can get 1 over RCS 1 plus 1 over RCS. Okay, class. Clear ke?
Clear.
Okay. Apa dia?
Clear.
Okay, okay. So, Madam susah hati kalau senyap je tau. Madam takut Madam cakap sorang-sorang. Okay, okay. Okay, so from here, supposedly you have to simplify this equation. So, how to simplify the equation? Macam mana nak simplify equation ni? Siapa boleh buat? How to simplify the equation?
Darab semua dengan RCS.
Darab semua dengan RCS. So, kita boleh cancel out kan? Betul? Sekejap Ni RCS 1 over S. So, kita akan dapat this one. RCS. Okay. So, meaning, sorry. So, when we simplify this one, we can get so bagi atas dengan so kita akan dapat apa? We can get 1 over RCS plus 1. Is it correct? Or like this mathematical? Okay, or we can maybe we can write like this. Okay, kita samakan pembawah. Okay, ini akan jadi RCS plus 1. Here and here we cancel. Okay, so we can get 1 over RCS plus 1. Is it? And then from here we have to simplify until we get the coefficient S is 1. Okay, you have to simplify until you can get the coefficient for S is equal to 1. So meaning from here, how to simplify? Okay guys, I ambil masa 2 minit je I come back.
Okay, madam.
Okay. Sorry, minum ada post laju. Biasalah musim-musim apa online kan, online shopping ni. Okay, so dengar tak? Clear tak?
Yeah.
Okay, so we continue. So dekat mana tadi? Okay, so from this equation, we have to simplify until we get the coefficient for S equal to 1. So meaning, how to get equation equal to 1? So meaning from here, we will get 1 over RC, S 1 plus 1 over RC. Okay, this is the equation we want to define. This is the transfer function we want to define. Okay, VI over V naught over VI, meaning output voltage over input voltage equal to 1 over RC over S plus 1 over RC. This is the transfer function we want to define. Okay, if this equation you draw into the block diagram, it's going like this. This is what? V, I. And this is our output. Okay, and then this one is a 1 over RC over S plus 1 over RC. Okay, finish. So, any question? Ada soalan?
No.
Okay, so far so good.
Yes, madam.
Yes.
Okay, very good. Okay, our attendance full 20. Is it? 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Wow, very good. The attendance full attendance. Okay, hold on, update our attendance, verify attendance. Okay,
Payah tanda kan attendance dekat Aris tu.
Madam buat.
Okay, thank you madam.
Okay. Everybody join our meeting today. Okay, right? Okay, dah siap. Okay. Now, let we see our next example. Cari yang susah-susah sikit. Example. Okay. Example number 2. Example number 2. Find the transfer function relating the capacitor voltage, meaning is C, to the input voltage. So meaning we want to define the transfer function. The output is a capacitor voltage over input voltage. Okay. So the fact, apa nak buat? The first step, what we going to proceed? What we going to use? What we going to write for the first step? Apa nak buat? Step 1, apply Kirchhoff law. So meaning you have to redraw the what? Equivalent transform impedance. Kita redrawkan balik. We redraw this circuit into the equivalent transform impedance tu. Okay, so similar like this. Question number 2. We redraw back. We can get this one. Is it? We can get this one. Okay, we redraw. Okay, RLC. Okay, RLC circuit. We redraw and then we label the impedance. Okay, so the second figure is we label with the impedance for inductor, for resistor, and for capacitor. Okay, once we relabel, the impedance, and then you can derive the equation step by step. Okay. Okay. First step. How to derive? Who can derive the first equation? Okay. This is actually this is from the mathematical equation. So from the mathematical equation, this is the transfer function. Okay, we want to define this transfer function by using block diagram. Based on mathematical equation, we already covered on Wednesday, right? Okay, so today, Maida want to share how to define the transfer function based on block diagram. Okay, so what first equation? What is the first equation for this circuit? Apa equation dia? Using Kirchhoff law. Apa equation dia yang kita boleh dapat? Guys, Vs equal to what? First equation.
LS.
Vs, okay, if let's say madam write down this, okay. Okay, so this one equal to Ls,
LS plus
okay,
IS.
plus
RIS
R I
IS
plus
plus
1
1
over
over
Cs.
CL.
Is
I
it? Is it
Yes.
correct like this?
Yes.
Okay. So this is the previous notes. Okay. This is our first equation, but we know voltage capacitor. Voltage capacitor. Let's say, mhm. Okay, let's say madam basi sikit ya. Let's say I put V naught here. Okay, I put V naught here, and then we define the transfer function. V naught over VIS equal to what? Okay, so now we finish our first equation. Okay, this is our equation number 1. So from first equation, what's that? Bunyi apa tu? So macam mana kita nak tunjukkan how you want to show the relationship between the output voltage V naught with the capacitor voltage? You have to show the relationship between both, because we want to define the transfer function of V naught. So you have to show the equation relationship between V naught and V capacitor. So meaning you have to write one more equation. V naught equal to
1
VCS.
over CS.
Yeah, 1 over CS multiply with the
Right.
IS. Okay, this is, yeah. Is it correct? Like this? This is question number 2. Is it correct, guys?
Yes.
Madam.
Okay, good. Okay, now we have 2 equations. So we finished to write 2 equation related to that system. Okay, so from there you have to rearrange equation 1, you have to rearrange equation 2 based on output equal to gain multiply with the input. Okay, still remember output equal to gain and multiply with the input. So you have to rearrange equation number 1 first. Okay, so how to rearrange question number 1? So meaning Vs equal to, this is the Ls plus R. This is our current, and plus V naught. Okay, like this. Is it correct? If I'm right like this, plus V naught. Okay, so from here we have two voltage. So meaning we rearrange the equation. So we make it voltage another one side. So we can get V
VS
minus
minus VO
V naught equal LS plus R,
plus
and this is IS. Okay, so meaning which one is our input from this equation? Which one our input? Which one our input? Because you still remember which our input? Our input from that
VS.
circuit. This is our input, yeah, VS. Okay, VS is our input. Okay, so meanings, of course, this is our input and this is our second input. Okay, voltage and voltage. So meaning, so from this equation, we have to rearrange to make it output equal to LS plus R is our gain, multiply with the VS minus V naught S. Okay guys, can you follow? Okay. So from there, you draw the block diagram. How to draw the block diagram? With minus here, meaning we have a two input, so we have a summing point. Okay. Then this is our input, first input. This is our second input, and then this is our. This is 1 over, right?
1
Is it correct?
over
1 over, right?
LR plus
Yeah, 1
R.
over. 1 over and plus R. And what's the output? Output is the current. Okay. So where is our second equation? Our second equation is V naught equal to, second equation is V naught equal to, okay, V equal to 1 over CS multiplied with the, okay, the first block, okay, the first block current is your output. So meaning the second block current is your input, right? So this is, oops, this is our input and this is our output and this is our gain. Okay, so from here, we already fulfill this statement. Okay, oops. We already fulfill this statement, right? Equal to gain times input. Okay, from there, we sketch or we draw the block diagram. So, input. Okay, this is your input, right? And what is the gain? Your gain with 1 over CS. And what is the output? Output is the V naught. Okay, guys. Okay, now we have two system. Okay, we have two subsystem and you have to combine to get complete block diagram. So you have to sketch back the overall block diagram or complete block diagram. Okay, so this is our input minus here. Okay, this is your V naught and this is our first block 1 over LS plus R, and from here we get output, right? And then output that goes to 1 over CS. And then what's the output? From here is a V out. Okay, V out is a feedback into the summing junction. Okay, this is the overall block diagram. And then here also H equal to 1. Okay guys, this is the overall block diagram. Belong to RLC circuit. Okay, can you determine the transfer function? how to determine the transfer function. Okay, this is the step how to define the function. Okay, so first you have to derive the equation, meaning you derive the equation you need to add to each other because from our previous meeting we derived the function based on substitute. Okay, from this topic or from this sharing session, we derive the transfer function based on block diagram reduction technique. So meaning no need substitute the equation each other. Okay, so to get the equation, you have to rearrange to get output equal to gain multiply with the input. Okay, once you get the equation, so you draw the block diagram, individual block diagram. Okay, and then the next step, you get the complete block diagram. Okay, now our step is we already get our complete block diagram. Next, you have to define the transfer function. Okay, what is the transfer function? How to define the transfer function? Okay, we have two block here. So meaning we have to combine A and B using cascade form. Is it correct? Using the cascade
Yes.
form.
Yes,
Okay,
cascade.
right. We combine two block using cascade. So the summing still there. Kita tak boleh simplify summing tu. Okay, summing akan hilang bila kita simplify loop. Or bila kita simplify feedback. Okay. Simplify feedback, the summing is missing. So currently we still have the output, come back. Okay, this is our output. Okay, and our H equal to 1. Okay, this is consider our 1 over R what? RLS multiply alamak okay, this is 1 LS plus R multiply with the CS. Is it correct? Like this?
Yes.
Yes.
Okay. So, can you define the transfer function? You have to minimize the loop or you have to minimize the feedback. Okay. So we use the formula feedback form. Okay, we use the formula feedback form. Formula feedback form. So make it be not as 1 over CS R plus LS over 1 plus because here minus, right? Okay,
Yes.
1 over CS R plus LS and multiply with 1. This is our H. Okay, so from here, class, you have to simplify until you get what? S. Okay, the coefficient S equal to 1. Okay, so you have to derive this equation. Okay, so you have to simplify the equation. How to simplify the equation? Okay, so meaning after you simplify the equation, okay, so madam, hopefully you do as your homework how to simplify the equation until you can get 1 over LC S square. We have from RLC circuit, we can get second order system because S square meaning for second order system, LS plus 1 over LC. Okay, this is the solution or the answer. From here to here, how to you what? Okay, you simplify the equation until you can get the last equation. Okay, we want to get this one. Okay, this is the term function we want to define. So meaning if we draw, oops, if draw the block, the last block diagram. Okay, so meaning if you want to represent into the block the overall term function. This is the overall term function. Okay, this one just now. Okay, this is the overall term function, and this is the complete block diagram. Which one our complete block diagram just now? Okay, this is the complete block diagram. Okay, this is a meaning complete block diagram to represent the RLC circuit. Okay, but this one is the overall transfer function. Okay, and then this is the overall transfer function for the RLC circuit. Okay, so meaning this is the V out, and this is the 1 over LC over S squared plus RLS plus 1 over LC. Okay, from here we already have a transfer function, overall transfer function, meaning we can analyze what type behavior of our RLC circuit. Meaning what type behavior meanings is you want to define whether our system stable, unstable, or critically stable. This is the behavior we want to analyze from the term function. Okay, so now we done to derive the overall term function, and then once you get the overall term function, we can analyze how the behavior of our RLC circuit. Okay, meaning is it our system stable, unstable, or is it our system marginally stable? Okay, guys, this is why we need to define the mathematical modeling. Why we apply maths model uh, to our system, to our electrical system. Okay, you still remember our introduction, why we need to define the mathematical model? Is this why we need? We want to define the behavior, whether our system stable, unstable, or critically stable. Meaning, we define from this transfer function. Okay, meaning, Madam give L equal to what? We give the parameter L. What's the value of L? What's the value of capacitor? What's the value of resistor? Okay, so based on the number. So we can get the number, you can define the, what? How to define the stable, unstable, or marginally stable class? Still remember how to define the stability from the transfer function? Who still remember when you learn circuit and, not circuit, signal and system? How to define the stability from the transfer function? Macam mana kita nak define stability? Based on pole and zero. Ingat ke? Syah ingat tak Syah how to define the transfer function, how to define the stability from the transfer function? Dia ingat tak?
Tak apa nak ingat.
Tengah mengingatkan diri.
Tak apa nak ingat. Aisyah ingat tak? Sen lepas. Aisyah belajar sen lepas signal and system. How to define stability from the transfer function. Macam mana nak define stability from the transfer function? Siapa ingat? Who remember? Brian? You can share how to define the stability from the transfer function. Do you already covered during your how to define the stability from the transfer function? Brian, Mark, and siapa lagi ni? John, Justin. You know how to define the stability from the transfer function?
Pakai post and zero tu ke?
No, ma'am.
Yeah, using pole and zero. Okay, so let's say from here we have now let's say from this system. Okay, madam just give example. From this system, I give you the real time function. Okay, let's say madam already give what's the value of L, what's the value of C. We substitute into this equation, so we can get V naught equal to Vi equal to, let's say this is apa ya, make it 10 lah So 10 over S squared plus apa? Plus 7S plus 10. Okay, so this is second order. So meanings from here, how to define the stability? Is it pole? Pole ke zero kat atas? Kat atas zero ke pole? This is your zero. Okay, from yang ini adalah your pole. Betul tak? Betul tak, Din? Betul tak, Din?
Ya kot.
Ya, rasanya betul.
Betul tak, Syah? Betul tak, Syah? Okay, good. Okay, betul. Okay, good. So, jadi ini adalah 10. Okay, macam mana kita nak? So, you have to factorize it. So, how to factorize this one? S 2, 5. Betul ke? Is it correct? 2, 5. Betul tak? So,
Yes,
bila
betul.
betul kan? Okay, so what's our pole? So meaning from this one, okay, from this one, our pole S plus 2 equal to 0, and then we can get our S equal to minus 2.
-2.
Yeah, another one, S plus 5
-2.
equal to 0, we can get minus 5. Okay, so how to define the stability? You draw into the S-plane. How to draw into the S-plane? Okay, this is what? J omega. Sorry, this is imaginary. Okay, this is the imaginary axis, and this is a real axis. Okay, so from the pole, yeah, sorry, okay, here and here, and this is your L bar. This is right kan? Okay, this is the RHP, and this is the left half plane. Okay, where is location of your pole? Location of your pole is here and here. Is it correct? -2, -5. Betul tak? Is it correct? The pole is there?
Betul.
Okay.
Yes.
Okay. So how about the stability?
Stable.
Stable, unstable, or critically stable?
Stable.
Stable.
Stable. Okay, stable, right? Because all fall on the left
Yeah.
half plane. Okay, so that's why we need to define the transfer function from the system. Okay, we want to analyze the behavior of the system. Now we know our RLC circuit condition is stable because the location of pole is on the left. Okay, guys, you got the information? You got the
Yes,
information
Yes.
or
definitely.
not? Okay, right. Very good. Okay, so far so good from our discussion just now.
Yes, madam.
Okay, very good. So hold on. So what about our next example?
Madam,
Hmm.
example 2 tu
Yeah.
kita kena tukar dalam value lah. Contoh ini contoh ataupun actual dia memang ada value.
ex-
For pole on 0, example.
Uh, okay, itu depends pada soalan. Kalau soalan tu ada bagi komponen tu, okay, komponen tu dia bagi equal, dia bagi value, kan? If the question give you value, so you kena substitute lah value dia tu dekat dalam transfer function. Okay, so meaning kalau let's say like if the question provide you value, so you have to substitute the value into the transfer function, and then from there you have to analyze. Okay, you analyze the behavior, whether stable, unstable, or marginally stable, something like that. But our first assignment ni sampai derive the transfer function saja, tak perlu define stability lagi. Okay. So our assignment until define the transfer function. That's it. From just now here. Okay. Our assignment or our take home test until here. Sorry. Until here. How to define this one. How to define the transfer function. How to define the overall transfer function for that system. Okay. Kita tak masuk lagi analyze the behavior. Analyze behavior chapter 4. Chapter 4 we covered. We analyze the behavior of the system. Okay, Din?
Okay, madam.
Okay, so this one madam record ni rasanya kejap. Betul tak? Kejap. Madam record, so nanti madam share lah video ni. Okay, our next apa? Dah habis dah kot. Ni dah habis lah ni example ni. Okay. So actually this is my plan. I give you two methods. First, you have to derive or you have to define the transfer function based on mathematical equation. Okay, meanings you have to substitute each other, okay, to define the transfer function. Or another one, we use the block diagram method, okay, to define the transfer function. We have two methods, okay. How to define the transfer function based on this kind of system. Depends whether electrical system or mechanical system is the same, how to derive, how to define the transfer function. Okay, guys, any question? Ada soalan sampai sini?
No.
So far so good? Okay.
So good.
Okay, if no question, madam want to discuss for our take home test 1. Okay, so I will give the assignment at 10 o'clock tomorrow. Okay, let's say madam write down here. Pukul 10 madam akan bagi soalan itu ya. Sekejap madam stop dulu ni. Mana nak stop? Sekejap. How to stop? Okay, clear. Sekejap. Stop sekejap.